Hello Team Kelly, this is lesson 2.4, all about multiples. You should be getting this written down in your notebook as well as today's date, so you can have a good source for your notes. Now when I look at that word multiples, I know that the prefix multi is in there, and multi means many. So many times over, multiples, comes multiplication comes from this as well, right? So keep that in your mind. That might help you with this lesson going forward. So here's a math message for you. If every week Emily earns $5 for doing her chores, how much money will she have after 1 week? After 2 weeks? 3 weeks? 4 weeks? 5 weeks? Write down the answers to that in your notebook, and then come back and take a look to see if we're on the same page. Okay, so hopefully you have that she would have $5 if she's going to earn $5 for each week, and then $10 for the 2 weeks, and $15 for the 3 weeks, $20 for the 4 weeks, and $25 for 5 weeks. Now, what pattern do you see in this answer? Really think about that. Jot down your thoughts, and then come back and take a look. Okay. So the pattern, you should see that we're increasing by $5 each time. We could also know that each of these answers are multiples of 5, right? Because you can see 5 times 1 for 1 week is 5. 5 times 2 for 2 weeks is 10. 5 times 3 is 15, right? So I can think about it like that. So here's a definition. You probably want to get this written down for yourself. A multiple of a number is the product. Remember, product is the answer in a multiplication problem. So it is the product of that number and another whole number, which is the thing I just said with you, with 5 times 1 equals 5, right? So it's the product of that number, 5, and another whole number, 1, right? A multiple can also be defined as a number that can be divided by another number without a remainder, right? With nothing left over, so it's evenly dividing, all right? So every multiple of a number is evenly divisible by that number. If we look at our answers from earlier, 5, 10, 15, 20, and 25 are all multiples of 5. All right, so make sure that makes sense to you. Jot that in your notebook. When you're done, come on back. So let's skip count by 3. That's another way that I think about multiples. I think about multiples as skip counting. If that's a comfortable thing for you as well, then jot that down. Multiples equals skip counting. All right, so if we skip count by 3, I'll circle that for you while you're doing the skip counting. So you to yourself out loud right now are skip counting, and you'd be saying 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30, right? Those are the multiples of 3. So my question is 27 a multiple of 3? And how do you know? The answer isn't because it's on the chart. How do you know? Think about that. Jot down what your thoughts are, then come back. Yes, 27 is a multiple of 3. I know because when I divide 27 by 3, I get a whole number, 9. So therefore it divides evenly, right? I don't have anything left over. If I tried to say 28 is a multiple of 3, I would be wrong, because if I divided 28 by 3, I would get 9 with 1 left over, a remainder. If it has a remainder, it isn't a multiple. Does that make sense? Okay, what other patterns do you see for the multiples of 3? Think about that. Jot down some thoughts. Come on back. Hopefully you see that the multiples on this one are alternating between odd and even numbers. 3 is odd, 6 is even, 9 is odd, 12 is even, 15 odd, even, odd, even, odd, even. That's interesting, right? Do you think that'll always be the case? We're going to talk about that in a second. Jot down your thoughts. Come on back. So now let's look at the multiples of 4. Is 24 a multiple of 4? How do you know? Do that same work right now, and when you have that set, then you can come on back. Yes, 24 is a multiple of 4. I know because 6 times 4 equals 24, so it must be a multiple. I could have also said because 24 divided by 4 is 6, because you know division and multiplication are related to each other, right? They're the opposite operations. So I could have said that either way. Both of those are correct, and if I do that division problem, it evenly ends up with the answer, right? That's how I know. So now, what patterns do you see in the multiples of 4? Think about that. Come on back when you're ready. Hopefully you notice this time that all of these multiples are even numbers. So I didn't want you to be confused that they would always go odd even. They won't. These are all even numbers. So that's something for you to think about as well. Of course, you know that 4 is an even number, so that should be in your thinking as well. All right, so let's look at how we can represent this understanding of multiples with an equation. Okay, with an equation. I did just show that to you, but let's see if you can think that through on your own now. So if we look at the multiples of 6, right, those are the ones I'm talking about, and we start skip counting by 6, how many groups of 6 are there in the equation? So if we start with 6, so if I'm only looking at this one right here, how many groups of 6 are there in that equation? Jot down your thoughts on that and come back. So if we're counting 1 6, one group of 6, think about now how can we record that with an equation? Jot your thoughts, come on back. Hopefully you would say, well, I can record that with 1 times 6 equals 6. It's an equation because I have an equals sign in between 2 different sides, right? I have all 3 parts, this side, an equals, and this side. That makes it an equation, right? So how can we record our second count? So if I started here with the 6, now I've skip counted to the 12. How can I represent that with an equation? Jot your thoughts and come on back. Hopefully you would say I could do 2 times 6 equals 12. 2 times 6 equals 12 would record our second one. So what would our third be? Our fourth be? Hopefully you can figure those out following that pattern, and that it makes sense to you that these equations could be used when we do the multiples of something. All right? So you should have gotten 3 times 6 equals 18, and 4 times 6 equals 24. Now I want you to think about the different parts of these equations. So which part of the equations show the multiples of 6? Think that through. Which part would that be called of an equation? Hopefully you'll be able to tell me it's the product or the answer of a multiplication problem, right? The answer is called the product. If you don't know that off the top of your head, you want that in your notes. It's going to be very important during this unit on multiplication and geometry, which is what Unit 2 is all about. So make sure that you have that in your notes. So it's the product that shows the multiple. So if I look back up here, I could see 6, 12, 18, 24, right? These are the multiples. So if we look at our 4 times 6 equals 24, hopefully we'll be able to say that the product of it is what shows the multiple. And then if I want to just have this in my notes, which I would, make sure that you understand that this would be a factor, and this is a factor, and the answer, the product, is the multiple. I think this is a really nice little handy thing to have written down for yourself so that you make sure that you connect those. So we're going to even go further with exploring that relationship between factors and multiples right now. So I want you to jot this chart in your notes and then fill in just this first column, the factors of 16. what would you multiply together to get to 16? Try and put them in order. So a 1 would be up here, hint, hint. What would go there? What's the second way? You might want to make that rainbow for yourself to get the factors of 16. And then we're going to come back and talk about the multiples in a minute. So get the factors jotted down, pause me, and then fill it out and come back. All right, hopefully you could tell me if I did that rainbow, I would see that I'm going 1 to 16, 2 to 8, and 4 is on its own, right? Those are the multiples, and that's how I use my rainbow to help me find the factors of 16. Okay, so now what are the multiples of each of these factors? As you list those, stop when you get to 16, because you could be going for a very long time, right? But stop when you get to 16 for each of them. When you have that done, come on back. Hopefully this is what you have on your notes now. You're noticing, or you're seeing that each of these, we could go to 16. 16 shows up in each of these, right? So you can see my 16. Oops, I'll stay with that red. You can see my 16 in each of these. All right, so I'm going to say that 16 is a multiple of every one of its factors. That is what I would notice. And you should know that, in fact, every number is a multiple of each of its factors. Okay? Every number. So this time we did 16. And when we did all the factors of 16, and then we do the multiples of those, they're always going to come back to that original number that we were talking about, the multiple. So think about that. If you want more proof of it, pick another number and do the same thing with that, and you will find the same thing. You're going to be doing something similar on your journal page, which is what I'm showing you right now. So journal page 41 is asking you to do a couple different things. You'll see at the top we're talking all about the multiples. Oops, I don't want to do that for you. I want to do this instead. We're talking all about the multiples in all of these lines. And then we're coming back again to look at the factors and the multiples. Okay? So do as much of this page as you need to. Make sure you get some of each kind of problem, though, as you're practicing it to make sure that you really get it. So make sure 10's included in your things that you try. When you have this page completed as much as you need to feel like you get this concept, come back and check the answers on the next part of the video and correct yours if you have it wrong. So then we'll know what we need to talk about when you come to the lesson. All right, so pause me right now and come back when you're ready to check answers. And there you go. There are the answers to this page. Hopefully none of this is too confusing for you, but if it is, make sure you talk to me about that when you're at the lesson so we can clarify anything that you might need. Okay, I hope you have a great night. See ya.